Have you ever marveled at the strength and elegance of titanium? This remarkable metal has found its way into everything from aerospace engineering to medical implants, and even luxury watches. But how is titanium made, and what makes it so special? Let's dive into the fascinating process that takes raw titanium ore and transforms it into the versatile material we use today. We explore the origins and manufacturing processes of everyday objects, revealing the hidden stories of innovation and human ingenuity. Every object has a journey from raw materials to the finished product, and we are here to uncover it. Join us as we peel back the layers of the ordinary to reveal the extraordinary history of the things we use every day. From the materials used to the techniques employed, we examine the evolution of manufacturing and its impact on our modern lives. Our journey takes us through factories, workshops, and laboratories, where we witness the transformation of raw elements into functional tools. We uncover the history of simple things, one object at a time, and share the stories that define our technological progress. Stay tuned as we continue our exploration of the world around us, uncovering the history of simple things. Titanium doesn't just appear ready for use. It's extracted from the earth in the form of ore. Most titanium is found in two main minerals, ilmenite and rutile, which are typically mined from open-pit mines. Australia, South Africa, and Canada are some of the largest producers, using heavy machinery to extract the ore. The mining process involves crushing and washing to separate the titanium-bearing minerals from other materials. Interestingly, titanium is the 9th most abundant element in Earth's crust, but it's rarely found in its pure form. This is because it has a strong affinity for oxygen and other elements, meaning it's usually locked up in chemical compounds. Extracting titanium from these compounds is no small feat and requires a multi-step process. The most widely used method for this is the Kroll process, named after William J. Kroll, who developed it in the 1940s. The process starts with converting the ore into titanium tetrachloride, a volatile and highly reactive liquid. The titanium ore is mixed with chlorine gas and a carbon source, such as coke, and heated to about 1000 degrees Celsius. At high temperatures, the chlorine reacts with the titanium in the ore, forming titanium tetrachloride, while impurities remain as solids. The titanium tetrachloride is then distilled to remove any remaining impurities, leaving behind a pure liquid. The next step is reducing the titanium tetrachloride into metallic titanium by reacting it with magnesium or sodium in a vacuum. The reaction produces titanium sponge, a porous, spongy form of the metal, and magnesium chloride or sodium chloride as byproducts. Titanium sponge is far from the shiny, strong metal we recognize, so it must be melted and refined. This is typically done using vacuum arc remelting or electron beam melting to create a homogeneous metal. The titanium sponge, often mixed with alloying elements like aluminum or vanadium, is melted in a vacuum furnace. The molten titanium is then cast into ingots, which are large blocks of metal that serve as the raw material for further processing. These ingots are then forged, rolled, or extruded into various shapes, such as sheets, rods, or tubes, depending on their intended use. This step involves reheating the titanium and shaping it with industrial presses and rollers. One of titanium's superpowers is its ability to form strong, lightweight alloys. Pure titanium is already impressive, but mixing it with other elements enhances its properties for specific applications. For instance, titanium aluminum vanadium alloys are commonly used in aerospace and automotive industries. They combine strength, corrosion resistance, and lightweight characteristics, making them ideal for demanding applications. The alloying process happens during the melting stage, where small amounts of elements are added to the molten titanium. This creates a material with tailored properties, making titanium incredibly versatile. It's suitable for everything from jet engines to prosthetic limbs. After the titanium is formed into basic shapes, it undergoes machining and finishing to meet precise specifications. Titanium is notoriously tough to machine due to its hardness and resistance to heat. Special tools and techniques are required to cut, drill, or shape it without damaging the material. Once machined, titanium products may undergo additional treatments, such as polishing or coating. For example, titanium used in medical implants is often polished to a mirror-like finish. This enhances its biocompatibility, while aerospace parts might receive heat treatments to improve their strength. While titanium is a remarkable material, its production isn't without environmental impact. Mining and processing titanium ore requires significant energy and resources. The Kroll process generates waste products that must be carefully managed. However, titanium's long lifespan and recyclability help offset these environmental costs. Many titanium products, such as airplane parts and medical implants, can be recycled and reused. In recent years, researchers have been exploring more sustainable methods for producing titanium. One promising alternative is the FFC Cambridge process, which uses electrolysis to extract titanium from its ore. This method has the potential to be more energy efficient and environmentally friendly. Now that we've explored how titanium is made, you might wonder why we go to all this trouble. The answer lies in its exceptional properties. Titanium is incredibly strong yet lightweight, resistant to corrosion, and able to withstand extreme temperatures. These qualities make it ideal for demanding applications, from building airplanes and rockets to creating durable medical implants. Moreover, titanium has a unique aesthetic appeal. Its silvery gray color and ability to develop vibrant, colorful patinas make it a favorite in jewelry and luxury goods. Despite its high cost and complex production process, titanium's versatility and performance make it an irreplaceable material. Titanium's journey from ore to finished product is a testament to human ingenuity. It's not just a metal, it's a symbol of what's possible when science and technology come together. As we continue to innovate, titanium's role in our lives is likely to grow, paving the way for even more incredible applications. So, the next time you see a titanium product, take a moment to appreciate the complex and fascinating process that brought it to life. Thank you for joining us on this journey through the history of simple things.